Hi, hello everyone. Today our chapter is periodic table, periodic properties and variation of the properties part 2, which is the continuation of the part 1. Okay. In this we are going to know about salient features of the modern periodic law, periodicity, shells and valencies. Okay. Now first we will go to salient features of modern periodic table. See, we all know about periodic table. We have learnt in the part 1. Now, you know what? It has groups and periods. What are the groups? Now we'll see. The periodic table has 18 vertical columns. The vertical columns are known as groups. It has 18. Previously, they used to call as 1A, 2A, 3B, 4B, 5B, 6B, 7B, 8 and 1B, 2B, 3A, like this. They used to name the groups in such a way. But now we name it as 1 to 18. There are 18 groups like group 1, group 2, group 3, so on, and group 18. Okay. Now, the elements of group 1, 2, 13, 14, 16 and 17 are known as the main group elements. These are all the main group elements. What are those? Group 1 is called alkali metals and group 2 is alkaline earth metals. Group 13 boron family. Group 14 carbon family. Okay. Group of 1 is what? Alkali metals. They form strong alkalis with water. They form a strong alkalis with water. Group 2 is alkaline earth metals. They form weaker alkalis as compared to the group 1. They form weaker alkalis compared to group 1. Next, group 13 is boron family. Boron is the first member of the group 13. So, we name it as boron family. And group 14 is carbon family. Here also carbon is the first member of the group and so we call it as carbon family. Next, group 15, that is nitrogen family. Group 16 is oxygen family and group 17 is halogen family. These halogen family they form salts. Okay, and the outermost shells of this group is always incomplete. Okay, there will be some stability for the outer shell configuration that is always incomplete in halogens. Okay, now third, that is the elements of 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12 are known as the transition. See, these are the transition elements which come in the middle of the periodic table. Okay, transition elements, they have two outermost shell incomplete. The outermost shells, two outermost shells will have incomplete. Okay, in halogens they will be always incomplete. In this transition elements, only two shells are incomplete. Okay, now next, elements in group 18, the last group, are known as noble gases or inert gases. Sometimes they are known as zero group also. Why? Because their outermost shell is always complete. They have a stable electronic configuration. Their electronic configuration will always be stable. They will not change at all. Okay, in this picture you can see group 1 is alkali metals, group 2 is alkaline earth metals, then 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 is transition elements, then 13, 14, 15, 16 is known as normal metals, that is non-metals. They have metalloids and metals also. And then the last 18th group is inert gases or noble gases or zero gases. Okay, next we'll come to periods. There are 7 periods in the modern periodic law. What are those? They are horizontal rows. These horizontal rows are known as periods. Okay, the number of shells present in atom determines in the period. See, there are for example, if you take the first period, the outermost shell will be one shell. The shell will be one shell. If you come to second period, the shells will be 2 shells. Like that, the number of period, the period number represents the number of shells present. First period, 1 shell. Second period, 2 shells. third period 3 shells. Like that it comes on increasing down the group. Okay. Here the first period contains only 2 elements, that is atoms 1 and 2. It is the shortest period we know. And the second and third periods contain 8 elements each, that is atomic number 3 to 10 in the second and atomic numbers 11 to 18 in the third period. These are also short periods. Okay. Then fourth and fifth period contain 18 elements each, that is from atomic number 19 to 36 in the fourth and the atomic number 37 to 54 in the fifth period. These are the long periods. Then the sixth period contains 32 elements, that is from atomic number 55 to 86. It is also a longest period. Then comes the seventh period, atomic numbers 87 onwards. Is at 8. It is 8 more elements to be added, so it is not yet completed. Okay, it is incomplete period. Seventh period is an incomplete period. Then in group 3 of the sixth period, in the group 3, sixth period, third group, there is a set of elements with atomic number 57 to 71, that is La to Lu. Okay, they begin from lanthanum, that is La is 57, and that group, that period, that is known as lanthanides. See, the elements starting from lanthanum till Lu, that is known as lanthanides. Then in group 3 of the seventh period, now seventh period, third group, there is a set of elements with atomic numbers 89 to 103. Okay, thorium to Lr. The beginning with actinium Ac. After Ac it comes Th. Okay, actinium is 89. There are known as actinides. These are known as radioactive elements, and lanthanide known as rare earth metals elements. Lanthanides are rare earth elements. Actinides are radioactive elements. Okay, we'll see the place of those lanthanides and this actinides now. In this periodic table you can see the sixth period third group, lanthanum. You can see down, you can see from lanthanum to 57 to 71, and actinides you can see there, actinium 1 AIC2, you can see there, right? Yeah, 103 atomic number 89 to 103 there, 57 to 71. These are lanthanides and actinides. Okay. Now, why these lanthanides and actinides are placed down the periodic table? Have you got the doubt? Yes, here is the answer now. Lanthanides and actinides have similar properties because they belong to same group. They belong to the same group of 3, but periods will change. So, lanthanides and actinides have the same similar properties. Okay, they are shown at the bottom of the periodic table because they are large in number. Okay, they are very large in number, and to show them in the main body, the table shape will be changed. The table shape will be changed, so they have kept down the periodic table. That's all. Okay. Then periodicity. What is periodicity? The properties that reappear at regular intervals, or in which there is a gradual increase or gradual variation, that is increase or decrease at regular intervals of time, and this is known as periodic properties. But this phenomenon we call it as periodicity. Okay, the properties of elements should reappear in the regular intervals. Regular interval means frequently they should reappear either by increasing or by decreasing. This process is known as periodicity. Actually, that is known as periodic properties, but this phenomenon we call it as periodicity. Understood? Now we will know about cause of periodicity. What is causing this periodicity? Okay, the cause of periodicity is the recurrence of similar electronic configuration. This similar electronic configuration causes the periodicity. Okay, in a particular group, if we take a particular group, electrons in the outermost shell remain the same. Now, what is outermost shell electrons? We know all electrons revolve around the nucleus in a shell. Okay, that electrons in the outermost shell remains the same in particular group. then the electronic configuration of that group also will be same. Okay, now since the chemical properties of elements depend upon the outermost electronic shell, okay, thus elements of same group have same properties. Now why we know, see, the elements of the same group has same properties. Why? Because the electronic configuration of that group will be same. Why? Because the outermost shell also will be having the same. Okay, outermost electrons also in that group will be same, and the chemical properties of that elements depend upon the outermost shell. So that particular group have same properties, that is similar properties. Okay, next comes for example, in group 17 group is halogens. Okay, all elements have 7 electrons in their, see, all the elements in the particular group, they have 7 electrons in the outermost shell. Okay, what happens, therefore they have some similar properties. All the halogens have the same properties. What are the properties? We'll see. They are colored non-metals. They form negative ions. We always see halogens as negative only. Then they are very reactive, and therefore they are always seen in combined state. See, they have only 7 and the outermost shell is incomplete. So they always react and they are seen only in combined state. Okay, and they are only slightly soluble in water. But they dissolve much better in organic solvents. They like if you take carbon disulfide, chloroform, alcohol, etc. And their melting and boiling points increase regularly moving down the group. If you come down the group, their melting and boiling points is increasing regularly. And they are good oxidizing agents. They form hydrides. When reacted with hydrogen, they form hydrides. When reacted with oxygen, they form acidic oxides. Okay, it is thus concludes that periodicity is due to the same number of electrons in the outermost shell of the different elements. Okay, see, this periodicity caused because of the same number of electronic configuration in the outermost shell. Okay, now we'll go to shells and valency. See, orbits. What is orbit? We know our electrons revolve around the nucleus in a way called orbits. Yes, electrons revolve around the nucleus in certain definite circular path called as orbits or shells. We call it as either orbit or shells. Now coming to number of shells down the group. If we come up to down, that is down a group from top to bottom in a periodic table, the number of shells increases successfully. That is one by one, such that the number of shells that an element has equals to the number of period. For example, if you take first period has 1 shell, second period has 2 shells, third period has 3 shells, like that. Number of period represents the number of shells when coming from top to bottom. Okay. Now, you can see here there is an example, element with atomic number 9, chlorine 17. See, the last column, period to which the element belongs, second, and the number of shell is 2. Then third period, 3 shells. Fourth period, 4 shells. Fifth period, 5 shells. Sixth period, 6 shells. Like that. Okay. Across a period. That is from left to right. On moving from left to right in a given period, the number of shells remains the same. Okay, for example, here the third period we have taken sodium, magnesium, aluminum, silicon, phosphorus, chlorine, argon. Like from 11 to 18 we have taken, every element have the same shell, that is 3 shells. Okay. Then comes valency. What is valency? Valency denotes the combining capacity of an atom of an element in an element. Okay, it is equal to the number of electrons of an atom can donate or accept. See, we have valence shell and we have some electrons there. How many electrons we can give or how many it can take, that capacity of an atom in an element is known as valency. Understood? Okay. On moving down a group, okay, the number of electrons in the outermost shell, that is valency shell, remains the same. Yeah, we know from up to down, top to bottom when you come, the valency shell remains the same. Therefore, valency in a group is also remains the same. Now, in a given period, the number of electrons in the valence shell keeps on increasing from left to right. But the valency also increases only up to the group 14. Okay, where it becomes 4 and then it decreases, that is in group 17 it has only 1. Okay, there is a note here. Velocity depends on the number of electrons in the outermost shell. Yeah. Okay. If the number of electrons present in the outermost shell are 1, 2, 3 and 4, their valency will also be 1, 2, 3, 4. Okay, respectively. If the number of electrons present in the outermost shell is 5, 6 or 7, then the valency will become, we have to minus that number. Like if it is having 5, we have to minus it from 8. 8 minus 5 is 3. If it is 6, we have to minus it from 8. 8 minus 6 is 2 and 8 minus 7 is 1 respectively. Okay. Then, thank you.